Good morning. We're going to go ahead and start with a problem of the day. So here's your warm-up problem that you can do either in your notes or in your homework. But what I would like you to do is take the function f of x equals square root of x, and I want you to describe, you don't have to graph, just describe the transformations in each of these three equations. Okay, if you haven't done so already, go ahead and turn and talk to your neighbors about your thought process so far. Okay, let's go ahead and talk about these. First of all, for number one, that 3 is a vertical stretch. So I want you to tell me that it is a vertical stretch of 3. Go ahead and be specific for me there. Okay. Then we have a shift to the right 1. Okay. For number 2, remember we need to do reflections first, along with shifts. So we have a reflection about the y-axis, since that negative is inside, and then we have a shift left 2, oops, I want the t in there, huh? Left 2 and down 3. Then over here we have a horizontal shrink because it's on the inside. Remember, it acts backwards. And then since 2 is the coefficient, 1 over 2 is the shrink that we would be applying. Okay. Okay. So we are going to take a quiz in the last part of class. Please remember that when you graph these, that you do need to give me 3 coordinates, okay? So if you are graphing an x squared that's been shifted, these 3 coordinates right here, 0, 0, 1, 1, negative 1, 1, those are the 3 that you are going to move. If you're graphing an x cubed, origin, 1, 1, negative 1, negative 1, those are the 3 that you are going to transform and then move to where they need to go, okay? Square root of x, 0, 0, 1, 1, 4, 2. Those are the 3 points you're going to worry about. See how quick those were to graph? If you have those coordinates either on your paper or in your head, then applying those shrinks or reflections or shifts are going to be very, very quick, okay? Remember, the point of this is to be quick with our graphs so that we can do other things with them, okay? I am going to start emailing you your quiz evaluations. You will physically get them back, but I know that they're already in the grade book and some of you are probably looking for that feedback. So I'm going to go ahead and scan them in and email them to you. So if you don't regularly check your email or you've been getting emails from Google Classroom that you kind of ignore, just make sure to be on the lookout for your quiz back, okay? All right, so today we are going to start section 1.8. We're going to do just a little introduction, really the very straightforward, simple part of it. And then the remainder of class will be your quiz that I'll grade over the weekend. And you'll get back Monday to more than likely do corrections on. And then Monday we will finish section 1.8. Okay, so 1.8 is all about the combination of functions. There are 5 ways to combine functions. Today we're going to talk about the simple 4, and then we'll save the composition for Monday. Now you've done all of this in Algebra 2, but we're going to focus a lot on the notation and the domain. So first of all, if you have 2 functions that you want to combine, we have to have overlapping domains. The domains don't necessarily have to be the same, but they have to have something in common in order to be able to combine them together in any sort of way. Okay, so like I said, notation and domain is what we're really going to focus on. So first of all, the sum, f plus g of x. This is what the notation looks like. And all we're doing is we're taking our 2 functions, as long as they have common domains, and adding them together. Okay, the difference, f minus g of x, we are taking our two functions and subtracting them. The biggest thing here to be careful of is when we subtract a function, we need to make sure we do it in its entirety. So if there's more than one term, it will need to go in parentheses. I know that that was something on, I think, 4C on your quiz. That was a struggle for some of us, is that we forgot to subtract the entire function. Okay. Next, we have the product, so f times g of x. And here we're just simply multiplying our two functions together. And then last, we have f divided by g of x, where we're just taking the two functions and we're dividing them, which really is going to be making them into a fraction, okay? The biggest thing, though, is that we don't want our denominator to ever be 0. So if there is a time where our denominator is 0, we will have to omit that from its domain. Okay, so we're just going to do one example of each of these with the same two functions. So let's go ahead and look at these two. I'll give you a moment to write them down. Okay, so first of all, let's talk about the domains of these two. F of x is, it looks like a linear function, y equals mx plus b, right? And so we know that any linear function is going to have a domain of all real numbers. G of x is also a linear function because it's in that form of y equals mx plus b. Or you can just notice that we have an x to the first power. So its domain is all real numbers. Remember, our domains don't have to be the same. They are in this case. They just need to be able to overlap somewhere. So that is definitely happening here. So we can go ahead and do our 4 combinations. So first, let's work on f plus g of x. This is the simplest of them all to do. We are going to take function f, and we are going to add it to function g. Okay, all you have to do is combine like terms. So it looks like we have x minus 3. I also want you to identify the domain. So since our sum is also linear, we know that we have a domain of all real numbers. Okay. Next, let's talk about, the subtraction. Okay. Here, we are going to take f, and we are going to subtract all of g. So please put g in parentheses, because that subtraction will need to be carried through. So we get 3x minus 7, which once again is linear. So we have a domain of all real numbers. Next, we're going to do multiplication. So we're going to take these and throw them in parentheses so that we can multiply them. Okay, so we're distributing, which we have two binomials, and so foiling is probably what you're used to thinking about. So we have 4x minus 2x squared minus 10 plus 5x. When I combine like terms, I really like these to be in order. So I'm going to write negative 2x squared first. Then I'm going to combine my x's to be 9x and then minus 10. Okay. Our product turns out to be quadratic. Any polynomial function is going to have a domain of all real numbers, if that helps you. Okay. So any polynomial, linear, quadratic, cubic, x to the fourth, x to the fifth, all of those are going to be polynomial with a domain of all real numbers. All right, and last but not least, we have division. Okay. The division is probably the easiest to think about because we're just going to take function f, put it in the numerator, and then put function g in the denominator. There is nothing we can do to simplify this, so we are going to leave it. But we do need to think about our denominator can't be 0. What would make our denominator 0? 2 would make our denominator 0. So we have to exclude 2 from our domain. So our domain is going to be everything to the left of 2 and everything to the right of 2, but 2 is in parentheses because we don't want to include it. Okay. So you have homework on your gold sheet, and it should be a very short assignment for you, shorter than you have been. And that's all you need to do this weekend. So what I'd like you to do now is pack up your things except a pencil. And you are going